In Unit 7, we are still talking about quadrilaterals and polygons. However, today we're going to focus on rectangles. So, the properties of a rectangle includes all the properties of a parallelogram. So if you look here, we see all the properties of a parallelogram. However, we're going to add two additional properties, two that you already know. 4 right angles. So if we take a look at a rectangle, we have 4 right angles. Okay, what is the second property we're adding? So the second property that we're adding is that the diagonals are congruent. So take a look at this. Here is a diagonal. It is, let's say, 10 inches. Here is a diagonal. It is also 10 inches. When we talked about the parallelogram, we said that the diagonals bisect each other. So if this one is 5, this side is 5. However, when we connect the other diagonal, this one could be 7 and this one could be 7. So that's the difference between the diagonals of a parallelogram and the diagonals of a rectangle. So with that in mind, those two additional properties we're adding, we are going to be able to do some of our guided practice. So as we read through the directions, it tells us that the figures are parallelograms in this set. And so let's go ahead and fill in what we know. And sometimes it may be too much information, but we rather have too much than not enough. We know that opposite sides are congruent. So PQ is 24. So SR is 24. PS is 10 and QR is 10. Now let's go over here and fill in what we can. QR is 10 units. S to R is 24 units. The next two, we would need Pythagorean's theorem. Not sure if you remember that from Algebra 1, but we're going to skip it for today. You want some enrichment, you definitely can ask your teacher how to incorporate that. QT, we would also need Pythagorean's theorem, so we are going to skip that one. Here, as we read through the directions, it tells us that each quadrilateral is a rectangle. So we have two additional properties. We know that each angle is 90 degrees. Let's see how this is going to help us. Well, if we know that each angle is 90 degrees and they told us a part of the angle is 27, we know that the other angle is going to be 63. Make it look like a 63 degrees. We also know that alternate interior angles are congruent. So this angle over here is the same as this angle over here, this angle over here. So we're going to go ahead and write 27 degrees. This little part over here is 63. And so therefore this part over here is also 63 degrees. I am going to redraw the figure so you can clearly see the alternate interior angles. 27, 27, and 63, 63. So since the diagonals are congruent, we have isosceles triangles. So this is also going to be 27 degrees, and its alternate interior is going to be 27 degrees. So let me put that on my picture down here because I feel like it's clear. So if that's 27 degrees, this one is also 27 degrees. Alternate interior, that would mean this one is 27 degrees. And this one right here is 63 and 63. So you can see the little triangles in there and how they are isosceles triangles. We actually could find out our angles in between because all three angles will add up to 180. Try to answer the angle questions, hit pause, try to figure out what it is, and then come back. Okay, so there we are. The only one that may have given you a little bit of trouble is M and L. However, the triangle looks like this. The bottom is 27 degrees. This one is 27. And to find X, you would add 27 plus 27 and subtract it from 180. For this particular problem, JM is a part of the diagonal, so we're going to go ahead and put in x plus 17. MK is a part of the diagonal. We're going to put in 5x minus 23. Because it is a rectangle and the diagonals are congruent, we're going to go ahead and set JM equal to MK. So x plus 17 is equal to 5x minus 23. Go ahead and put your algebra to work and let's see what you get. We get x is equal to 10. Let's read the directions. It states to find JL. So JL is the whole diagonal. So J to L is equal to x plus 17 plus x plus 17. Let's see what you get. Voila, JL is equal to 54 units. Here we must find the measure of angle BCE. We always want to concentrate on the letter in the middle, that's the vertex. So if we go from B to C to E, what we're talking about is this part of the angle right in here. So let's see what we can do with that. We know that alternate interior angles are congruent. So this angle right here is going to be congruent to this angle here. So we're going to go ahead and set that equal to each other, push pause, put your algebra to work, and then come back. We see that x is equal to 2. However, that does not answer the question. We're going to go back and plug it in. And when we plug it in, we get that angle is 19. The question is that the angle that we are looking for? That is not, again, the angle we're looking for. But we'll go ahead and fill it in. This is 19 degrees and this is 19 degrees. What do we know about a rectangle? We know that every angle is a right angle, which means it adds up to 90. So what do you think we're going to do to find that angle? You got it. We're going to subtract it from 90, and we get that this angle over here is 71 degrees. So I'm going to come over here and draw the picture again. So here we go. This angle over here is 71 degrees. This angle is 19. This angle is 19. This angle is 71. This angle is 19. This angle is 71. This angle is 71. And this angle is 19. Welcome to the world of rectangles. Try this one on your own. See if you can set it up correctly and remember your properties of a rectangle. Well, the first thing I'm going to do is mark my alternate interior angles. So this angle here, represented by x plus 20, is the same as this angle over here that does not have anything. But what we do know is that the whole angle adds up to 90. And so the alternate interior angle with 5x minus 8 would be right here, 5x minus 8. So what is the setup? 5x minus 8 plus x plus 20, plus x plus 20 is equal to 90 degrees. Do your algebra and then answer the question. We get x is equal to 13. So we're looking for angle XZW, and that is represented by 5x minus 8. So it's equal to 57 degrees. Let's have a quick review of what we know about rectangles. So what we know about rectangles, the diagonals bisect, so they're going to be equal. We know that each angle is 90 degrees. And we also know that alternate interior angles are congruent. So if this angle over here is 30 degrees, then this angle over here is also 30 degrees. They make up isosceles triangles. So 30 degrees is going to be the base angles in those opposite triangles. Well, if they both add up to 90, then this angle over here would be 60, and it's alternate with this angle over here, which is 60. And it would be 60 in this isosceles triangle, and this would be 60 in this isosceles triangle. So these are some of the things that can help us remember what to do with the rectangle. So at this time, we are going to do our independent practice, a few more problems, and then go on to homework number 3.